Okay, today's video we're going to be covering bend topography in Vision. Bend topography is basically calibrating your machine with your materials and your tools so you can bend more accurately in terms of your flange lengths, your flats, with your bend deductions and your bend angles. So we have a procedure we follow on the Vision machines to do this, and we'll be reviewing that. If you plan on doing precision bending, you need to calibrate your machine to get the maximum results. The Vision machine comes with a standard material database that was produced with press brake tooling that you may not have. So to get the best results, we need to do several test bends with the material and tooling you plan on using, and to every gauge you plan on bending. If you only need to produce parts from the 32nd or worse, the tolerance, 16th or so on, this step may not be necessary for you. The existing database might be suffice. But if you want to just improve your angle precision, not correcting so much, then this would be beneficial and worth doing. Also, so you're aware, this is also calculating the bend deductions for the tools that you're going to be using with that material. So we accomplish several things in this task. So stick around, we're going to cover more info. Okay, first, before we go any further, I want to show you something. I'm going to show you our bend tables. And our bend tables is where this calibration data is going to be going to. And it will be, you won't actually be editing any data in there, but I want you to see what it looks like. And you can get an idea of what it's all about. So here I'm going to select the material. This basic window here, you see a material type here. I select it. Okay, like steel, that stands for steel AccurPress. What you'll see here, like right now I have K factor selected, and what it shows me is a K factor based on the V width, okay, and by gauge. So you look up through our chart, up to here, you can see what Vision is using. If you select, say for instance, 11 gauge and a 630 V opening for a die, and you're going to get that 0.489 K factor. So they have also can do it with bend allowance and also bend deductions. Okay, same thing. So when we calibrate a material, we're going to be making a new material on this list because these are locked. We can't touch those. So we're going to edit our own. You want to give it a name that makes sense to you, that you easily identify. That's up to you. And so we'll create that material, and then we will go and calibrate it. But first, we're going to show you how to create this material. So under this setup button here, this window pops up and material type shows, and you'll see this. We need to create a material first, so let's just copy an existing one. The only thing you need to know is a name and a tensile strength. And these tensile strengths can be found online very easily. Just look up your material tensile strength and you'll find some numbers. So we're going to do, since this one's highlighted, we're going to copy it because tensile strength will be the same. I'm going to copy this to, I'm going to say NS steel. Okay. And I'm going to hit, I can put some additional descriptions. If you want to put additional data about your material, you can put it in there. And I'm going to hit yes. So my new material is created here, and I'm ready to move forward. I'm going to hit close here, and we're done in here, so I'm going to hit exit. You'll get this updating bend database notice. Let it complete, and we're ready to move on to the next step. Alright, next thing we need, I want to show you some things that we need for measuring once we do our calibration. We'll need a pair of calipers. We'll always need these for measuring our blank sizes. Okay. We can also use them for measuring after we bend the parts, but for thinner material they're a little tough because they have a tendency of flexing the material and we'll get bad numbers. Another item I use personally is this 2-inch travel indicator. I use that to measure the parts after they're bent, and it works very nice. It's very repeatable. I also made sure I put a flat tip here because I'm measuring on some curved surfaces, so I want to get a good measurement. So that's another item I do. Of course, the other thing, a digital angle finder was a good tool to have. You can use the analog ones, but they're pretty subjective when you read off the numbers. This one is one or the other, very discrete. So these are the tools we need to do our test bends. Okay, real quick guys, what I have here is my 3 blanks that I prepared to do our test bends, 2x2s. And what I do is I measure each one, check the thickness on each one. Also, I measure the width and the length, and I note it, as you'll see here. And here, I'll write down the dimension for that width and length. Obviously, I indicate the angle that I'm bending with this piece. And I have this little arrow over here. You can see them on these. What I use that arrow is for orientation. My arrow, when I'm bending, points towards the back gauge finger, and I will use that also to help me measure. When I'm measuring these pieces, I want to measure always on the same side of the plate, just in case I'm bending slightly crooked. On my dies, I will have a different length on either side, so I always measure from one side. That eliminates that possible error. When measuring these, just be careful when you're doing it. We want to use your calipers and be square up on the plate so we get a good measurement. Very critical. Once you have these ready, we're going to go and program our machine and start doing a bend. Okay, in our next step, we need to make our program for our first bend. So we're going to come over here, start a new file, save all changes. Nope. On our material, remember we made a new material earlier. We're going to select that NS steel, and we're going to give it our thickness. I'm doing 16 gauge, and my 16 gauge happens to measure 0.055. Okay, and I'm going to give it my blank length of our square. Remember we said 2 inches, but we're given actual numbers that we measured with the calipers. So in my case, blank length in X is 2.017. Okay, the next one, my blank width is going to be 1.999. Okay, so that's all good. We're going to OK here. We're going to move on to the next step. Whoops. Let's draw our shape. Okay, next we're going to dimension it. We're going to just make it a 1 inch by 1 inch. Okay, 90-degree bend. That's good. And next we're going to do a sequence. Okay. And I'm going to come here and check my tools real quick. Yep, 021 is good. Let's see this lower. I actually am not going to be using a 394. I'm going to be using a 472 for this material. And this is the tool that I got. So I'm all set there. So this is important. When we're calibrating, you hopefully will be using the same die all the time. If you're going to be mixing it, this won't work. When we actually program a part, once we're calibrated, it's going to look at the tool combination that you have and know what numbers it uses from the database. So be very aware of that. Very important. So program's ready. Hit OK. And we're going to go ahead and actually bend it. So we're going to hit the start button and ready to go. Okay, well now we're going to measure our first part after bending it. As you can see here, I'm going to use this arrow to help me locate where I'm measuring. And make sure you're zeroed before you measure. And I'm also going to push down with my finger here to take note of the number. That looks like 1.90. Okay. Our next height. Again, pushing down. Measures 1.046. 1.046. Okay, use this next bend. Again, look where my arrow is. I'm going to measure this height. Okay, so guys, 1.490. Okay, and this last measurement is we got to measure the height of the teepee. Arrow again. We're going to measure right here. Pushing down always. 0.729. Okay, we finished our first bend. Now we're going to go in and put the numbers into Vision, so we can calculate our new numbers for our database. So we're going to go down here to Setup, go to Settings. Okay, we want to be in Bend Topography. If it didn't ask you for a password, you're good, but normally it will, and that password is 1701. So you'll see here, let me close this out, it input all these numbers from our program. Okay, so all we have to do is input these numbers that we measured. Okay, so just be double sure everything is critical here. If your flat length was entered wrong, bend length is entered wrong, any of these numbers, or definitely any of these numbers, if they're wrong, it won't calculate, or it'll give you an error, or give you bogus numbers. You gotta be very careful. We're gonna input all four of these numbers. It's gonna calculate an angle. We're gonna compare that angle to what we measure on our test piece. And if we're within a half a degree, we are good to go. Okay. So if everything's done right, it should be just fine. So let's put in some numbers here. Okay. All right, so that's first number. My first height is going to be 1.087. Okay. Second height is 1.046. 0.046. Okay. Next number is going to be the bend height. That's 0.729. Okay, last number, bend base width. That's going to be 1.489. 1.489. Hit OK. Alright, so what happens? It comes over here and gives you these results. It gives you, okay, it repeats what you just input here, but it also comes up with bend deduction, inside radius that's calculated, K factor, and the angle that's calculated. So if you look at this and you measure your part, I'm measuring mine right now, and it is 88.7, well within our half degree. So that's pretty good. That's we like that. And if that all looks good, we hit the plus sign. And what that'll do is enter those values into our database. So now we'll go and do the other two parts and do this over again. Okay, now we're going to make our second program to bend our second part. I'll start over. And again, I'm going to select my NS steel, 0.055 for material thickness, my blank length for my second piece. Okay, so that dimension is going to be 2.019, and then the other one, 1.999. All right, so this one a little different. We're going to do a 120 degree. Okay, same deal, 1 inch, 120, and we're all good. Sequence. Okay, I'm going to double check my tool. 052, that's the one I want. Okay, and we're ready to run. One note I don't think I mentioned on my earlier program is when I'm doing this profile mode, it's going to put in a bend deduction. So what we do need to do is we want to bend these pretty close in the middle. So to ensure that on our test coupons, go to under flange mode, under bend, under BD for bend deduction, make that 0. Okay, what that'll let us do is it'll put our back gauge right at that 1 inch that we want. And we're pretty damn close to 2 inches here, so it'll keep our flanges similar in length, or not very off. You don't want them to be too far off center. Makes the math harder. So we're set there. We're ready to bend this part, and we'll be right back. Okay, we've bent our part. Now we're going to input our information. So again, let's go to Setup, Settings, Bend Topography, put in our password 1701. Okay, so it's got our new Y bottom, it's got our new information here. So we're ready. Just input our new numbers. Keep fingers crossed. So first height 0.920. Second height is 0.881. Okay, this next height is 0.514. And the base width is 801. Okay. There's our new numbers, and what I always look for is bend deductions or bend radiuses that are out, that just aren't from out of this world. Like we would never have a 3/4 inch bend deduction. That should be a clue that something's not right. The system will also, if it has problems, with some of these numbers, it'll just tell you invalid numbers, makes you do it again. So you got to go look through all your numbers. I did that earlier. We had some wrong numbers and it wasn't working. But you just go through it. It's very literal, and small changes make a big difference on the end result. So I'm going to measure my piece. It's telling me it's calculating 122.13, and my part is measuring 122.2. Plenty close. That's pretty on the money. So I like that. So we'll take that and we'll add it in. Now we'll go bend our next test part and enter that in. Okay, now we need to program our third and final for this gauge material. So I'm going to hit new. I won't save that old info. We're going to put in NS steel 0.055. Let's hit OK here, and let's enter our new blank length. Let me look it up here. 1.997, 1.997, and 2.017. Alrighty. Again, this isn't acute. We'll go ahead and change this. Dimension it 1. I'm going to say 45. We're all set. Let's sequence this. Let's check our lower. That's all good. Okay, we're all programmed up. Just another reminder. Let's do this. Go to your bend. Let's get rid of that bend deduction. We don't need that. Okay, just keep bending on center a little more. So we're ready to go. and we're going to run this program. This is because the tonnage is so low, no big deal. We'll keep going, run it, and we'll be back and we'll measure and enter the info. Okay, part's bent. Now let's take a look, and we've measured it all, so let's input the info into Vision, and we'll go by, once again, setup, settings, Bend Topography. I was here earlier, so it's still open, so it's going to take my new numbers, okay, and then we're going to enter our new information. Obviously it brought in everything from before, so let's input our new info and let's see how she looks. Okay, first height 0.820. all right, second it's 0.791. okay, our next is 0.925. that's for our bend height. And again, last one, not least, that's our base width, 0.859. Alrighty, telling me a 40-degree bend. We'll see what she says. Okay, I am measuring 40.6. So that's good. That's good stuff. We can use that. That will do us. So we're good there. And we'll accept this. Okay. And so that material is completed. Okay. You'll want to do this to all your other materials. And keep in mind, these numbers, you don't have to be off by a lot. It's real easy to punch in the wrong numbers or note the wrong numbers when you're measuring them. So be real particular. Look at these numbers, give you some clues if something's radically off. You know, look at your IR, look at your bend deduction, look at your K factor. You probably have an idea where they should be, so take a look at this. Now I want to show you real quick, before we wrap up, what this all just did. So what we're going to do is we're going to go to our bend table again. It takes a second to open up our bend table. Alrighty, so here's our bend tables. If you'd have looked at this earlier today before we did our calibration, you would have seen a whole lot of nothing. Much like you do right now. The only deal is we have one material calibrated. Okay, 16 gauge with a 0.472 V die. Okay, and there it's telling me my bend deduction. I can see my K factors. I can see Y factors if you use that. Okay, I want to see my bend allowance. Okay, so the more you do, so if you do different gauge with this combination of tooling or different tooling, it'll start building this table out. But in terms of this particular gauge material with this V die opening and this soft steel, you're good to go, and it'll handle all the angles in between. So that's what it's doing, pretty much just as if we were to look at this table. Whoops. Okay, there's just entries for the different gauges with the different V dies. So if you want to do your 16 gauge with a different combination of V die, maybe a 394 because you want a tighter radius, or 315, you would do a calibration with this and do the same thing we just did. You would do that for every material you want to do with every combination of tools you want to use. Okay? This will help you be a lot more accurate. Will make your life real easy. It's completely worth doing, and you really don't have a choice if you want to be a real precision house. Okay? Very important. That's it for now.